Hi, Assalamualaikum. My name is Muhammad Amir Hafizi bin Muhammad Rohazan. My matrix number is B091810182 under supervision of Encik Haris Fadilah bin Zainuddin. Today, I would like to present about my final year project, and the title is Investigation of Mechanical and Physical Properties Reinforced Composite of Natural Fiber Using Taguchi Method, Oil Pump. So for the presentation outline, which is first one is introduction, problem statement, objective and scope of this project, research methodology, result and discussion, and the last one is conclusion. So we go through to the introduction. First, biocomposite typically consists of one or more stages of natural fiber reinforcing with organic matrix of biopolymers. They are commonly worked in a wide range of applications including aircraft structure, automobile parts, building materials, and sporting products. Biocomposite proponents claim they are safer and healthier to produce, lighter than wood, and more environmentally friendly. Biocomposites are also gaining popularity in fundamental research due to their several advantages including being renewable, low cost, decomposable, and biodegradable. Then we proceed to the problem statement. The usage of biodegradable natural fiber in polymer composite as a replacement for petroleum-based polymers as well as conservative non-renewable polymer composite has its own set of benefits, including in strength qualities, low cost, and low density. Moreover, it has a good thermal of stability and provide much excellent in their insulation against heat energy. And last one is effect to the environmental issues. For the objective of this project, first one is to investigate the physical properties of oil palm fiber, reinforced cassava starch, glycerol, and PVA. Second one is to investigate the mechanical properties of oil palm fiber, reinforced cassava starch, glycerol, and PVA. And third one is to investigate the factors that influence in mechanical and physical properties by using Taguchi method. Then we go through to the scope of the research. First one is carry out water absorption test in accordance with ASTM D570 for the physical properties. Second one is carry out the tensile testing in accordance with ASTM D638 for the mechanical properties. Next, by using Taguchi method as a finding the optimal weight and size of the fiber and matrix reinforced composition for oil palm fibers strengthened with cassava starch, glycerol, and PVA. Next, we go to literature review of this project. First one is Composite Material, authored by Rajak and Akil. The reinforcement of a matrix structure is used to create two distinct materials with distinct properties. Composite material may also comprise additive core component or fillers, and they have different qualities than traditional materials that they are used to manufacture. Second one is Biocomposite, authored by Roy and Akampomoza. A biocomposite is a composite material made up of a matrix resin and natural fiber reinforcing. Natural fiber has been used as reinforcement in polymetric composite as a result of environmental concern and the high cost of synthetic fiber. As is generally known, strengthening fiber in various polymers considerably enhance the mechanical properties of composite in the aircraft and automobile industries. Synthetic fibers such as glass and fiber are preferred for polymer reinforcement. Third one is oil palm, authored by Rodriguez, Wahida and Najmuddin. Oil palm fiber has been shown to be a good raw material for biocomposite when isolated from empty fruit bunches. OPF has cellulose in the range of 43% to 65% and lignin in the range of 13% to 25%. The addition of oil palm fiber to some polymetric matrices increased the strength of the resultant composite, while in others less strength was found. And the last one is oil palm product, authored by Loboda and Khalil. There is an abundance of oil palm trunk in Malaysia due to the large production of main product from oil palm. The oil palm trunk is made up of vascular bundle and parenchyma and is produced from the oil palm tree. The annual production of oil palm trunk was estimated to be over 33 million tons. Research methodology. This is the flowchart for PSM2. This project was started by sample preparation. The preparation of the sample begins with the purchase of raw material for the fabrication of new composites such as cassava starch, oil palm fibers, glycerol, and PVA. On the next step, we go to the factor and level selection. Then, we can start mixing all the composition. The mixture of the composition was then created in the mold to form a comparison sample and ready to be compressed in the hot press machine. After that, the sample was processed before moving on the next phase to determine the mechanical properties and physical properties of oil palm in the polymer matrix. The entire sample was examined using the tensile test according to ASTM D638 and the water absorption test according to ASTM D570 after it had been truly cured. After that, we can go through to the result and discussion of this project. For the first one is tensile test. The tensile test sample was made up to ASTM D638. The acquired load data may be converted to the engineering stress and a stress strain graph shown. After testing, the results show as ultimate tensile strength. Tensile strength is the maximum stress that a structure can endure under tension. The sample break as the engineering stress reduces. The sample will fracture if the force is applied continuously. For this tensile strength test, in particular, the quantity of cassava starch which include flexibility and high tensile strength are most adversely affected. This is the figure of main effect plot for signal to noise ratios that are created from Taguchi analysis in Minitab. In addition, since cassava starch has an excellent addition in characteristic, a high tensile strength is required for the bonding between the structure of the matrix and the reinforcement before the connection may be cracked. Second one is the main effect plot for signal noise ratio show that cassava starch has the biggest impact on the SN ratios, which support the results. The SN ratios of the experimental runs with 40 grams of cassava starch were significantly higher than those with 30 grams of cassava starch. For the minor influence in this main effect plot for SN ratios, signal noise to ratios, included the size of the fiber. Next one is for the water absorption test. Water absorption test according to ASTM D570. The test must be performed with the sample immersed for 2 hours in the water. The sample thickness and weight were found to have changed. For this water absorption test, in particularly the size of the fiber and the composition of cassava starch, which include the moisture content, are mostly affected. This is the main effect plot for signal to noise ratio for water absorption tests that have been created in Taguchi analysis in Minitab. So, in this situation, the purpose of this study for physical attributes desired larger of moisture content is preferable. This is because the larger the moisture content, the greater it can absorb water into the samples. So, it is suited for various purposes and applications. In addition, Because size of the fibers and composition of cassava starch has an outstanding adhesive qualities, a larger water absorption for the individual samples and it will begin rising in weight and thickness too. After that, for the minor impact in this major plot effect plot for signal to noise ratios incorporated the composition of PVA. Lastly, we can proceed to the conclusion of this project. Generally, this research is concerned with the influence of matrix and fiber size on the tensile test and water absorption test performed on this material. The purpose of the tensile strength test is to investigate the influence of the composition in the test related to the different properties of the material used. Aside from that, the water absorption test is used to identify which composition is the least effective at absorbing water based on its properties. Unaffected by this, one of the frequent behaviors that occur in biocomposite materials, which was also discovered in the present study, is that the mechanical properties are often considerably more scattered than those of the other biocomposite. Specifically, in this situation, the oil palm fibers will be manufactured in a tightly regulated environment, resulting in fibers that are almost devoid of defects. So that's all from me. Thank you. Assalamualaikum.